Hello everyone! Previous video I've taken a look at quadratic equations and how to solve them using the product is zero methods. Okay? Well, today I'm going to take a look at theory C, which is kind of the same but a bit more difficult. Well, is it really that more difficult? We will see in a moment. Before we're going to answer that, I'm going to take a look at exercise 55, because I think exercise 55 answers a question that some of you may be asking yourself. Which question? Well, from a times b equals 0, it follows that a equals 0 or b equals 0. But you cannot say that a times b equals 12 results in a equals 12 or b equals 12. Use a few examples to explain this. So they say that if I have 0, I can say that either one of them is 0. But if I have a times b is 12, then I cannot say a equals 12 or b equals 12. How does this work? Well, like this, right? Just one counterexample is already enough. Let's say a equals 2. Well, if a is 2, then 2 times b is 12, then b is 6. Therefore, now I have a and b, and neither of them is 12. One is $2 is 6. So I cannot use this rule if I have 12 on the other side of the equal sign. If you remember correctly, I asked two questions previously. I've asked the question, is it equal to 0 and is it a product? And previously we said yes, it's equal to 0. There was a 0 on the other side of the equal sign. Here it isn't. And that's a factor that we can, or that's something that we can solve, right? How are we going to solve this? Well, let's take a look. And by the way, it's not a product either, right? So we have to solve both those problems. How can we get rid of this 12 on the right-hand side? Do we have a way to do that? Yes, we do, right? What we can do is we can make the right-hand side 0 by just subtracting 12 to the left and to the right-hand side. And that's actually the only step that I now have to do, because if I do it like this, now my right-hand side is 0. This is not a product yet, but this is something that we can now solve using the product sum methods, with the sum being 4 and the product being minus 12. Think about it for a moment. Which numbers can that be in this case? Well, I think the only possibility in this case is going to be plus 6 and minus 2. Which means either this thing is 0 or this thing is 0, right? Because this is a times b equals 0. Write down this step, and now you should know that we can solve this by writing down this next step as well. Okay? So what is different? Now we have to make the right-hand side 0. Let's try that again. But before we're going to try that again, I want you to be careful when you arrange terms using the product sum method. Let's say I have this thing on the left and the thing on the right, which are exactly the same. I want the right-hand side to become 0. How can I do that? Hopefully you answer by doing plus 5x to the right-hand side and therefore also on the left-hand side. Like this. But here is a small thing which can go wrong. Here I put my 5x at the end and here I put it in the middle. I would like you to try and put them in this order. This is mathematically correct, because I can rearrange plus terms like this. But if you're going to write down like this, there's a fat chance that you're going to now do the product sum method incorrectly. Because for the product sum method, we are used to this order: x squared, x's, and numbers. And now I know that my sum must be 5 and my product must be 6. So not like here where I say, well, this is the second thing, so my sum must be 6. No, my sum must be 5. But up until now, we're used to this order. So I want you to write it down in this order, so you do not do that wrong after this. First the x squared, then the x's, then the low numbers. Okay? And this is already 7.5. This is something that I'm going to talk about next time. If I am on this slide, take a look at this example right here. And I think you should now be able to solve this equation by yourself. Good luck. If you have any questions, please let me know.